Okay, this is the next recording for practice materials. I'll do some later questions. I skipped a few, just trying to get the ones that I think are most important for you to be able to see me work through out first. So let's go to the practice exam. We'll work on these set of 4 questions here, which relate to the binomial distribution, and then we'll do a couple with this uniform distribution, which is things that we're going to be talking about tomorrow. So the first one, we have this information given to us. 40% of credit card customers carry a balance from month to month. Suppose we want to interview 10 credit card customers. Okay, so someone either carries a balance each month or they don't, so that's our success failure. The probability any one person carries a balance is 40%, so the probability is 0.4. And then we're looking at 10 credit card customers, so we can think about our n there as 10. So right away, just going to keep some things clear here. We've got n is equal to 10. Probability of success is equal to 0.4. Right? And the first question asks us, what's the expected number of customers who carry a balance? Well, if we look at this formula sheet, right, we've got these equations down here. So this group of equations is for our binomial. Here's our probability mass function for the binomial. Here's our mean and variance for the binomial. So to find the mean, we simply take the number of trials times the probability of success. So up here, that would just be n times p, which is equal to 10 times 0.4, or 4 customers are expected, right? Or the mean or the expected value is going to be 4 there. Okay? So this should hopefully be a pretty easy question. If we're asked this on the exam, this should be one that people can get some easy points on. The next one we ask is, what's the variance? Well, if we go here, we have our variance equation. It's just n times p times 1 minus p. We've already identified n and p, and so here it's n times p times 1 minus p, which is simply equal to 10 times 0.4 times 1 minus 0.4, or 0.6. If we enter this into our calculator, I'll kind of work along here, we should get 2.4. Right? Now, I could have instead asked you a different question, which is not just the variance, but what's the standard deviation? So if we wanted the standard deviation, the only other thing that we have to do is take the square root, and I'm typing what it would be in Excel here. Hopefully that's clear. I could actually, insert an equation. We'll get, where is it? It's right here, right? Take the square root of 2.4 instead. Right, just another way of typing that out. Maybe it's easier for you guys to see. If we end up working that out, it should be what? 1.55-ish if we round to the second decimal. So that's just another question I could have asked there. From there, let's actually start using that probability mass function for the binomial. So we've got, what's the probability that exactly 4 customers carry a balance? So the way that I would do this is I'd write down, what's the probability x is equal to 4? We have our n, we have our p, we now have our x value as well. So we go to that formula sheet, we're reminded, here's the probability mass function for a binomial variable. If we want to find the probability x is equal to 4, we plug in x is equal to 4, n is 10 in our example, and the probability of success was, what, 0.4? So now it's just a matter of plugging those values in and getting that from our calculator. So I'll minimize this so that we can see that formula. Right? And I'll just start typing it out in the context of our example. So we've got what? 10 factorial divided by 4 factorial times 10 minus 4 factorial. And we'll then multiply that by the probability of success, 0.4 to the power of x. Our x is 4. And we'll multiply that by 1 minus the probability of success raised to the power of n, which is 10, minus our x, which is 4. Right? So, like I said, we could break this down into parts. Another thing we could do is, before I write this out, let me just do the math I can do in my head. 10 minus 4 is 6. Let me get rid of those parentheses. 1 minus 0.4 is 0.6. 10 minus 4 over here is 6. Right? So now I kind of simplify it, make it a little bit easier to put into my calculator. Or, if we're comfortable, and this is where I think Excel can be helpful on the exam, but if we're using questions incorrect, or if we're using formulas incorrectly, we could get wildly incorrect answers. So I'll show you what I mean here. So let me zoom in on this. So let's say we wanted to use that binomial, built-in binomial distribution. So our number of successes we're interested in is 4. Our number of trials is 10. Our probability of success was 0.4, and we want to make it, we don't want it to be cumulative, right? We want the probability exactly 4 customers, okay? So I hit enter here, I get about 0.25, right? So if I enter this in my calculator, I should be getting this value of 0.025. Now, if I made a mistake and entered these in incorrectly, notice I get an error, right? Or if I had instead forgot and made this cumulative of 1, I'm going to get a wildly incorrect answer. All right? So I need to make sure I know how to use those functions in Excel. If you're not super comfortable with them, because Excel is doing things, a black box behind you, I would double check this by trying to, work it into your calculator as well. So even if you want to use Excel, if you got the extra time, I would definitely double check your answers, entering this into the formula and putting it into your calculator. Okay. So what if we want the probability that at least one customer carries a balance? So once again, just write down what we're looking for. So at least one would be that the probability of X is greater than or equal to. Once again, I'm going to type this in like I would in Excel, but you can imagine if I had a greater than or equal to sign here, I could go to insert and some symbols. So I want to know, is it greater than or equal to 1, right? At least one customer. Well, said in class, the way that we would do this is find the probability that whatever fits this criteria, all the different outcomes, and add up all those probabilities. So the probability of 1 plus the probability of 2 plus the probability of 3, all the way up to the probability of what's our last possible outcome we could see, 10, right? Because we only have 10 trials. Well, that's going to be using that binomial equation a bunch of times. There's probably an easier way to do this. We said if we think about X being greater than or equal to 1 as event A, what would its complement be? Because we know the probability of an event is equal to 1 minus its complement. So where does that come from? We actually have this right here, right? So I can either write this as the probability of the complement is 1 minus the probability of the event, or if I rearrange this a little bit and just I'm looking for the probability of A, probability of A would be equal to 1 minus the probability of its complement. Okay? So what would A complement be here? Well, if A is that X is greater than or equal to 1, a complement is that it's less than 1. So what are the only outcomes that fit this criteria? Well, X can't be 1 because the equality is not on there. So the only possible thing I could see that fits that criteria is that X is equal to 0. From there, I need to find the probability X is equal to 0. My N is still 10. My probability of success is still 4. So I would now just be plugging things into my binomial equation over here in my formula sheet, but now X is 0, right? So I'll type that in. So 10 factorial divided by 0 factorial times 10 minus 0 factorial, right? Times 0.4 to the X. Well, my X is 0. Times 1 minus 0.4, whoops, to the N, which is 10 minus X. Now notice anything to the 0 power is 1. So even if I enter this in my calculator, this will just be a 1. 0 factorial is 1. So this essentially is 1. Now I have 10 factorial divided by 1 times 10 factorial. So the 10 factorials cancel. This is essentially all just 1. And really the only thing left I have now here, I could simplify this. This would be 0.6. 10 minus 0 is just 10. So my answer is going to be 0.6 to the 10th. All right? So if I enter this in my calculator, I should get something pretty close to 0. If I round it to the second decimal, I think it's 0.006. If I round to the second decimal there, I should get 0.01. Now the problem is I forgot a step, right? I would get this wrong because what I found was the probability X is equal to 0. So I still need to subtract that from 1. Which gives me 0.994, rounded to the second decimal would be 0.99 there. Okay? So that's how we can use the complement rule in conjunction with that probability mass function for binomial distribution to find this. Okay? So this kind of is just a short video on the binomial distribution questions that you could see on the exam. So the next kind of question that we want to work through will not be binomial, but I'll work through a quick Poisson one here at the end of this exam. So let's assume the number of people struck by lightning every year is approximately 3 people. What would be the probability that less than 2 people are struck by lightning this year? So first of all, we've got a time interval, right? Where was it? 1 year. We know the average rate over that year, so we should be using that Poisson distribution, or the probability mass function for the Poisson. Our lambda is the average rate, which we're told is 3. Our e is just this kind of natural number e. And then our x is going to be, well, we're not sure yet. It depends on this problem. So what are we looking for? We want the probability that x is less than 2. So this would be the probability that x is, we would take all the possible outcomes here. The very first possible outcome that fits this criteria is that x is equal to 1. Add to that the probability that x is equal to 0, and then 0 is as low as we can go. So I'm going to have to use this probability mass function 2 times, once where x is 1, once where x is 0. Okay? So the probability that x is equal to 1 will be lambda to the x. So my lambda here, I was told, is 3. So 3 to the x, well, here I'm looking at x is equal to 1, okay? Times e to the negative lambda, so e to the negative 3. I'll then take that and divide it by x factorial. So my x is 1 factorial. Right? I then want the probability that x is equal to 0. Same kind of idea, except for now, my lambda is the same. It's still 3, but my x is now 0. So 3 to the 0 power times e to the negative lambda divided by x factorial. Right? So I go ahead, I enter this into my calculator. Oh, where's my e? There we go. E to the negative lambda. So this first one should be at 0.149. Okay? And then the second one, oh, and I made a mistake here, sorry. I missed my to the power sign. Sorry about that. So this one I get about 0.049. Is that correct? Yep. So if I want the probability that less than 2 people, well, I have to add these together. So I'll take 0.149, add that to 0.049. So I guess if I'm rounding these to the second decimal, we should get about, whoops. There we go. You actually do should get 0.198. Once again, kind of it's because I rounded the third decimal here. If I kept it out to more decimals and then rounded my answer, I would have got 0.199. But I'll make sure on the exam I'm choosing numbers where kind of if you round whatever, I guess the rule of thumb for the exam should be whatever the answers are displayed in, you can round the intermediate calculations to that same value. And clearly, if you get 1.98, it's not going to be them giving you answers that, like where I have 0.199 and 0.198 as possible answers. Okay? So whatever the decimals are in here, when you're doing the intermediate calculations, round to that same number of decimals. The reason why I got a little bit off here is because I was actually doing everything on my calculator and not rounding anything. Okay? So that is a good example of Poisson distribution equation, and this kind of ends this little section of exam review.